Dynorphin, the brain's stress and discomfort signal. Not all neurotransmitters make us feel good. Some exist to slow us down, signal danger, or create discomfort when something is wrong. Dynorphin is one of these chemicals. It is not about pleasure. It is about control, stress, and limits. Dynorphin helps the brain respond to pain, stress, and threat by pushing experience in an opposite direction to reward. Dynorphin is an endogenous opioid peptide. Endogenous means it is produced naturally by the body. Opioid means it binds to opioid receptors, but dynorphin is very different from endorphins or enkephalins. While those often reduce pain and promote comfort, dynorphin is strongly linked to negative emotional states. It is sometimes described as the brain's anti-reward chemical. Dynorphin was discovered in 1979 by Avram Goldstein and colleagues. Researchers were studying endogenous opioids and noticed a peptide that behaved very differently from others. Instead of producing pleasure or relief, this peptide produced aversive effects. They named it dynorphin. The name comes from Greek, meaning powerful or forceful. Dynorphin acts primarily on one receptor type. This receptor is called the kappa opioid receptor. This is a key difference. Endorphins mainly act on mu opioid receptors. Enkephalins often act on delta opioid receptors. Dynorphin prefers the kappa receptor, and activation of this receptor feels very different. When dynorphin activates kappa opioid receptors, it reduces dopamine release. Dopamine is central to motivation and reward. By reducing dopamine, dynorphin suppresses reward signals. The result is often feelings of discomfort, dysphoria, or emotional flattening. This is not a mistake, it is a feature. Dynorphin is heavily involved in stress responses. During intense or prolonged stress, dynorphin levels increase. This acts as a brake on reward and motivation systems. In effect, the brain is saying, "This is not a time for pleasure. This is a time for caution." This makes dynorphin part of the brain's threat and survival system. When conditions are harsh, reward seeking can be risky. Dynorphin suppresses reward to prioritize safety and energy conservation. From an evolutionary perspective, this makes sense. Dynorphin is found in many brain regions. These include the amygdala, hypothalamus, hippocampus, and nucleus accumbens. These areas are involved in emotion, stress, memory, and motivation. Dynorphin is especially active in circuits that regulate mood and coping. One of the clearest roles of dynorphin is in stress-induced negative emotion. High dynorphin activity is associated with anxiety-like and depressive-like states. It does not cause depression by itself, but it can contribute to feelings of hopelessness, low motivation, and emotional pain. This has made dynorphin a major focus in mood disorder research. Animal studies show that increased dynorphin activity can produce behaviors similar to depression. Blocking kappa opioid receptors can reduce these behaviors. This suggests dynorphin is part of the biology of stress-related mood changes. Dynorphin also plays a role in pain. Unlike enkephalins, which usually reduce pain perception, dynorphin has complex effects. In some contexts, it can reduce pain. In others, it can increase pain sensitivity. This depends on where and how it is released. Dynorphin is especially linked to chronic pain states. Dynorphin is also involved in addiction. This may seem surprising at first, but it plays a key role in withdrawal and relapse. During repeated drug use, dynorphin levels increase. This suppresses dopamine. The result is reduced pleasure and increased discomfort. This contributes to tolerance. The same drug produces less reward. It also contributes to withdrawal. When the drug is removed, dynorphin-driven dysphoria remains. This negative state can drive relapse. people seek the drug not to feel good, but to stop feeling bad. In this way, dynorphin is deeply involved in the dark side of addiction. It does not create pleasure. It creates the emotional pain that sustains compulsive use. Dynorphin also interacts with learning and memory. Stressful experiences associated with high dynorphin release are often remembered strongly. This may help organisms avoid danger in the future. However, when overactive, this system can contribute to rumination and negative memory bias. Dynorphin therefore sits at a crossroads: stress, pain, mood, motivation. It links all of these together. Here are some everyday style examples that help illustrate dynorphin's role. First, after prolonged stress, when motivation drops and pleasure feels muted, dynorphin is likely active. Second, during withdrawal from addictive substances, dynorphin contributes to dysphoria. Third, in chronic stress, dynorphin suppresses reward-seeking behavior. Fourth, when negative experiences feel especially persistent, dynorphin-modulated memory systems may be involved. Fifth, when stress makes normally enjoyable activities feel empty, dynorphin is acting as a brake on dopamine. There are several important facts about dynorphin. It is one of the most potent endogenous opioids. It has strong effects even at low concentrations. It primarily activates kappa opioid receptors, and its effects are often aversive rather than pleasurable. This makes it unique among opioid peptides. Dynorphin does not act alone. It interacts closely with dopamine, corticotropin-releasing hormone, and stress hormones like cortisol. Together, these systems shape how the brain responds to adversity. Dynorphin often acts as the chemical signal of enough. Enough reward, enough stimulation, enough risk. In recent years, there has been growing interest in drugs that block kappa opioid receptors. These drugs aim to reduce dynorphin's negative emotional effects without producing addiction. They are being explored as potential treatments for depression, anxiety, and addiction. Research is ongoing, but the system is promising. From a broader perspective, dynorphin helps answer a difficult question. Why does the brain sometimes make us feel worse under stress? The answer is not cruelty. It is protection. Dynorphin shifts behavior away from risk and toward caution. So what is the big picture? Dynorphin is not a pleasure chemical. It is not a reward chemical. It is a reality check chemical. It signals hardship. It suppresses reward. And it helps the brain adapt to difficult conditions. Without dynorphin, organisms might take dangerous risks under stress. With too much dynorphin, life can feel bleak and unmotivating. Health lies in balance. Understanding dynorphin helps explain stress-related depression, addiction relapse, chronic pain, and emotional resilience. It reminds us that not all brain chemistry exists to make us feel good. Some exists to keep us alive. So the next time stress drains enjoyment from life, remember this. There is a chemical system in the brain designed to shut down reward during fret. That system is dynorphin. Powerful, protective, and when overactive, deeply challenging.
If you enjoyed our channel, please click subscribe.